focused our energy on the last lesson graphing inequalities for absolute value. So today we're going to focus similarly on graphing inequalities with respect to quadratics and what that might look like. So I've got some steps to help us here identify these techniques. And of course, using graphing technology will certainly be a benefit, using the similar ideas that we had utilized when we were graphing absolute value inequalities. So the first step is to rewrite the inequality, if necessary, as a quadratic function on one side of the inequality and 0 on the other side. Next item is to find the zeros. Remember that zeros are the same as x-intercepts are the same as solutions. So what are the solutions? And place them on the number line. Then we'll choose some test values in each interval to determine if we're going to shade or not shade, depending upon if we're less than or greater than 0. Choose the intervals which correspond to the correct sign that solve the inequality. So here we've got our first example. We're going to do it both algebraically, just like we did the inequalities for absolute value. We'll do it algebraically, and then what does it look like if we were to use graphing technology to help us? So our first one here is looking for 2x squared is less than or equal to 3 minus x. So the first step is to rewrite the inequality as a quadratic on one side and the inequality with 0 on the other. So in order to do that, I'll subtract 3 and add x and bring that to the left-hand side while writing it in descending order, giving me 2x squared plus x minus, plus x minus 3 is still less than or equal to 0. Then we'll go ahead and solve. We need to now find the zeros. So there's a couple ways we could do this. We could factor, or we could utilize the quadratic formula. And since we haven't used the quadratic formula in our notes yet, I'm going to go ahead and use the quadratic formula because I know A is 2, B is 1, and C is -3. So x equals the opposite of b plus or minus the square root of b squared minus 4 times our a value times our c value all over 2 times our a value. The opposite of b plus or minus the square root of 1 squared is 1. Let's see here. -4 times 2 is -8. Times -3, that gives me positive 24, all over 4. Oh, happy day, we have -1 plus or minus the square root of 25, that'll be useful, equal to 4, over 4, excuse me. So then this gives me -1 plus or minus 5 over 4. So it's going to look like we're going to have some fractions as our results, right? We're going to have -1 plus 5, which is 4 over 4. So we'll have 4 over 4, or -1 minus 5, -6/4. So then, of course, we can reduce these. We can reduce these down to 1 or -3/2. So factoring probably wouldn't have worked out very well since we don't have whole numbers with us, but all the same. All right, so now we need to determine where are we going to shade, right? We need to figure out where we're going to shade. So I'm going to draw a little number line over here. Let's see here, -3/2 would be on this side. 1 would be on this side. It can equal, right? It can equal. So these points would be equal to. Now, just a matter of where we're going to shade. So I need some test points. So I'm on step 3 where I need some test points. I'm going to choose a value that's less than -3/2, so less than -1.5. So -2 would be to the left. That area would be covered. In the middle, 0, a nice number, would be included. And then let's see here, 2. So that all 3 sections tells me what it's going to look like. Then what I'm going to do is substitute those values into my function. So 2 times 2 squared plus 2 minus 3. When I substitute these values in, I'll have, let's see here, 2 squared is 4, 8 plus 2 is 10, minus 3. Doesn't matter what the result is. I know this is greater than 0. So everything to the left of here is going to be positive. Now I'm going to do the same thing for 0. If I substitute 0 in, 2 times 0 squared plus 0 minus 3. Of course, my finger's getting in the way over here. I apologize for that. So 2 times 0, so this is 0, 0, negative 3, so we're less than 0. So in this instance, we're negative. And then finally, I can check 2, and this was negative 2, I apologize, negative plus negative. We'll still be positive anyways, it doesn't matter. And we just said if I did positive, positive, we would be positive. So we're looking for values that are less than 0. The only place within our number line here that we are less than 0 is in between here and here. And notice because these are solid dots, these get to be included. So the interval is from negative 3/2 to 1, and both are included because we have the less than or equal to sign. Well, how does this look when I'm graphing? How does this look when I'm graphing? Notice I set my quadratic and solved it, setting it equal to 0, just like we did here, just as we also had done with with inequalities with our absolute values. Notice it's giving us those points that we had indicated here. And we know these points are included because these are zeros of the equation, right? These are zeros for the equation. Well, when I'm looking at my graph, we're looking at our y values. Our y values are positive on this side. Our y values are negative down here. And then they become positive again over here. We know that these points are included. So it matches exactly what we had graphed with just the number line itself. Visually seeing that, yes, in fact, our function is negative in between negative 1.5 or negative 3/2 all the way to 1, both points included. So I've got the steps up above. We've got x squared minus 2x is greater than 1. So the first thing we're going to do, of course, is set it such that 0 is on one side. So therefore, I just need to subtract 1 and bring it over to the left. So I'll have x squared minus 2x minus 1 is greater than 0. Again, let's just jump to the quadratic. I've graphed it. Clearly, those values are not nice, neat numbers where the zeros are located. So we'll use the quadratic formula. So x equals the opposite of b. So our b value is negative 2 plus or minus the square root of b squared, negative 2 squared, minus 4 times a times our c value, all over 2 times our a value of 1. And then we'll simplify. So we'll have positive 2 plus or minus the square root of 4 plus 4 all over 2, which of course is the square root of 8. That's not a nice, neat number. That's kind of ugly. All over 2. I know 8 is the same. To simplify this, 4 times 2, and I can take the square root of 4, so I'm going to simplify this radical. This gives me 2 plus or minus 2 square roots 2 over 2. Now, since everything is divisible by 2, we can certainly go ahead and do that, giving us just 1 plus or minus the square root of 2. So my two solutions are 1 plus the square root of 2, which is an ugly number, and 1 minus the square roots of 2. So when I think about my number line here, we're going to have 1 plus the square root of 2 on the right, 1 minus the square root of 2 on the left. So I need some test points. So let's see here, 0 would be a good one. Let's see here, 1 minus, so then negative 1 would be easy to substitute in. And then on the right-hand side, perhaps, well, I know it's 2.4, so like 3. It's a nice whole numbers that we can substitute into the equation. So again, if I did negative 1, I'd have negative 1 squared minus 2 times negative 1 minus 1. giving me 1 plus 2 minus 1. It doesn't matter. It's greater than 0. So it's positive over here. If I substitute 0 in, we'll have 0 squared minus 2 times 0 minus 1. So 0, 0. This is going to be a negative value in between those two characters. And then if I tried 3 squared minus 2 times 3 minus 1. So here 9 minus 6 minus 1, we're still greater than 0 over here, which does in fact look like our graph, right? But this time we're looking for where is our values, our y values greater than 0. These are open points here and here, right? Because it's just greater than. Where are we greater than 0? We are greater than 0 this direction towards negative infinity, and this direction towards positive infinity. So my interval is going to be negative infinity all the way until I reach 1 minus the square roots of 2. Hop over the center because we're negative in the center. 1 plus the square roots of 2 to positive infinity. And that certainly does match our graph, right? Where are our y values positive? They're positive over here. They're negative in between here. And then they are positive again over on this side. The downfall to doing it this way is that it's not giving us the points, whether they should be solid or open. We have to look at the symbol to determine that. So I'm going to say here and here, right? Because we know those are open circles. And that matches what we did algebraically to determine. Let's try this guy. We have something a little different. We've got x squared plus 1 is less than or equal to 2x. Same idea, we need to subtract 2x and bring that over here and put it in descending order. So we'll have negative x squared minus 2x plus 1 less than or equal to 0. And again, I'm just looking at our zeros when I graph it to help us verify, because in my open math, it's most likely going to ask you for the exact values rather than just the decimals. So in this instance, we're really going to have to rely on our algebra and the graphing tool to help us. So let's see here. X is opposite of b, so opposite of negative 2 plus or minus the square root of b squared, negative 2 squared, minus 4 times a, which is negative 1, times c, which is positive 1, all over 2 times a, which is negative 1. And then start simplifying. 2 plus or minus, let's see here, 4 plus 4. Oh, we have the same kind of issue, except we have negative in the denominator. This gives us 2 plus or minus the square roots of 8 over, and we'll just move that negative up front. That'll be useful for us. All right, I know from our last one that 8 is the same as 4 and 2, where I can take the square root of 4, which gives me 2. Negative 2 plus or minus 2 square roots 2 all over 2. So because all of these are easily divisible by 2, just the factored form. Notice I'm not dividing inside because algebra tells us we cannot do that. It's inside. Only the things that are factorable can be divided by 2. Thus, negative 1 plus or minus the square root of 2, and then over 1. So we have two solutions this time. Negative 1 plus square roots 2. Negative 1 minus square roots 2. So again, we have our number line to double check. And we are equal to here. So I've got on the left, negative 1 minus square roots 2 will be smaller than negative 1 plus square roots of 2. And these will be closed circles. If my fingers would stop touching things that they shouldn't. Okay, closed circles. And now we need to choose points that are left, in the middle, and to the right to see what is happening on either side. So I might choose something like -3, that's a nice whole number. In between these two might be -1. Since I'm subtracting and adding to -1, -1 has to be in the middle, and then 0 has to be, oh, nope, not quite. That's not quite enough. Let's do +3. That way we know for sure we're on to the right-hand side. And then we'll test those values. When I substitute -3, and I'll have -3 squared minus 2 times -3 plus 1. Let's see here, that gives me -9 plus 6 plus 1. I'm still negative over here. If I do -1, so -1 squared minus 2 times -1 plus 1. This gives me -1 plus 2 plus 1. Doesn't really matter what the number is, I just know I'm positive. And then if I try 3, -3 squared minus 2 times 3 plus 1 gives me -9 minus 6 plus 1, super negative. Doesn't matter what the value is, I just know I'm a negative sign. Here I'm looking for where are we less than or equal to 0, so I'm looking for the negative. So I am negative coming from -infinity all the way until I hit that first 0. I have to hop over the middle, and then all this area to the right is negative. And that also matches the graph. It matches the graph. Notice that we've got our solid points there. It tells us that they're solid, but we have to look at the inequality to verify whether they should be solid or open. And then I notice that my graph is negative. My y values are negative over here. My y values are positive in the middle. And then my y values are negative over here. So when I'm looking at my inequality, it's going to be in between here and here. So we write that, of course, as we're coming from -infinity all the way until we hit that first 0, which is included, and notice it's put it in its exact value. We're going to hop over the middle, the positive area, start at -1 plus square roots of 2, and then we can continue to positive infinity. And so this would then be, of course, our solution, using both algebra and graphing technology to help us. So the last couple are looking at solving inequalities with respect to an application type problem. So here I've got the profit in dollars made by selling X bottles of 100% all natural, free trade organic Sasquatch tonic is given by -x squared plus 25x minus 100, where our X value, so the number of bottles that we sell, has to be between 0 and 35 bottles. How many bottles must be sold to make at least $50 in profit? So we've got two different inequalities that we're looking at here, right? We want to know then where we are selling at least this many bottles, or at least this much profit. So when I'm looking at this equation, I'm going to say -x squared plus 25x minus 100. I want this profit to be at least $50. So I want to have $50 in profit exactly, right? So notice then in my two different, we'll finish solving this here first before we go any further. So I'll subtract 50 from both sides so that I have -x squared plus 25x minus 150. Of course, where is this greater than 0? And now we can solve. The first thing I'm going to do is divide everything by -1 because I'm pretty sure I could factor this just looking at these values. So what multiplies to 150 but yet adds to -25? Let's see here. -15 times -10. And -15 plus -10 gives me -25. So I'll have -1, x minus 15, x plus 10, excuse me. Minus 10, goodness gracious. Okay, once it's factored, we set each factored piece equal to 0, and then we'll solve. Well, this doesn't make sense, so we just ignore that. So x has to equal 15, and then x has to equal 10. So when I'm putting this on my number line to determine, we have 10 and 15 where they can be included, because we can have $50, but we want at least $50, so more than $50, right? And I could substitute some values in here. So in between here, we would be greater than or equal to 50. Here would be less than 50. And here we would be less than 50 over in these areas. So what I did to help us graph this a little bit is I put the function that we have here. So this was the left-hand side of our inequality up above. And then I can't just put 50 in, right? We're asking for where is y 50, right? Where is y equal to 50 is what we're looking for on the right-hand side. And so that's why I put y is equal to 50 on for the right-hand side. So then it graphed two pieces. So notice then in our picture, our graph is less than $50. Our y values are less than $50 over on the left-hand side. And it's less than $50 on the right-hand side if you were to substitute values in. We are more than $50 in between the intersection of 1050 and 1550. So we must sell between 10 and 15 bottles. So or 10 to 15 using interval notation, but in realistically what it looks like here. Another similar problem where we're setting it equal to a value, the height in feet of our rocket. So we have a similar rocket that we talked about the other day, except this particular rocket has a different height function. And t is t seconds after liftoff. T has to be between 0 and 20 seconds. When is the rocket at least 250 feet off the ground? When is it between? And notice here, we've got the same function. I've got negative 5x squared plus 100x on the left. And then down below, I've got y equals 250 because that is our location here. And notice in this particular example, our x values are represented in time. X equals t, which we know is representative of time. And it's in seconds. So we certainly could solve by saying, well, I'll have negative 5x squared plus 100x equals 250. Or we want greater than 250 here, greater than or equal to, because our rocket has to be greater than 250 feet off the ground, or at least, greater than at least, same thing. But then I'd have negative 5x squared plus 100x minus 250 is greater than or equal to 0. And you could certainly, of course, do the quadratic formula. You're going to come up with two solutions. Our two solutions are going to be 10 plus 5 square roots of 2 and 10 minus 5 square roots of 2. But if you had told somebody, I just went 10.5 or 10 plus 5 square roots of 2 seconds, they're going to look at you weird because that's not how we talk, right? If I'm talking about seconds, it's okay to use decimals in the context that we are using it. So here we're going to skip right to the graph part because we don't specifically need the exact value because that's not appropriate to the context of the question. So where is my rocket then? Above 250 or at least 250 feet off the ground. And notice that it's in this area in between here and here. We are at 250 since this marker is the 250 feet mark that is graphed. Here we are less than 250 and here we are less than 250 feet off the ground. So our interval in this case is between 2.929, because we're in seconds, It makes more sense to put seconds rather than 10 plus or 10 minus 5 square roots of 2, all the way until we reach 17.071. Again, we're in seconds. So in between about 3 seconds and 17 seconds, our rocket is above 200 or at least 250 feet off the ground. Anywhere else before 3 seconds and after 17 seconds, we are less than 250 feet off the ground. So context matters with if we can just jump to the graphing portion or if we have to use some algebra to help. So be careful of the context of the question.